can. Hello, Mateo.
Alright, this is a Spirit Plumber from Robots Everywhere. I am going to be showing you how to build a solar charger for your phone. Now, one thing to be understood is solar panels come in two varieties. Normally you can get them in any kind you want, but when you buy them on Amazon or something like that, they're going to be coming in 5 volt or 12 volt. Now, 12 volt are supposed to be connected to your car. These are 5 volt. Now, you might thinking, USB is 5 volt, these guys are 5 volts, so why don't you just connect one of these and call it done? You can't, because the amount of voltage and current coming out of a panel is actually relative to the amount of light. So if you're getting like an overcast day like today, you're gonna get 3 or 4 volts out of this guy and your phone will not charge. If it's a sunny day in the summer, you're gonna get 8 or 9 volts out of this, which will blow your phone up. So you need a regulator. Fortunately, regulators are super cheap. You can get one of these guys for exactly $1. Get them on Amazon, get them on DigiKey. Now, these are 5 volt panels, and what we're gonna do is that we're gonna connect them together so that they give you 10 volts. And the reason for that is that if they give you 10 volts, that means that when it's overcast, they're still gonna give you, 6 or 7 volts, letting you charge. And when it's really bright, they're gonna give you 15 volts, let's say. The job of this circuit is to take whatever voltage comes in, it could be 6, it could be 15, and give you a clean 5 volts so that you connect your phone to it without fear. Very important.
And the rest just builds up in the panels that you're not using, or is it kind of lost?
No, this is a switching regulator. What you described was the old kind, was the linear regulator. Switching regulators are more clever. They lower the voltage, but they ramp up the current, so your phone actually gets more power.
Oh, okay.
These guys are good. Again, these are $1. They cost $1.15 with shipping, I think. They are about 97% efficient, which is almost as good as you can get them.
Yeah.
And they're super easy to set up. Now, I have built a little rig here to let you change the voltage that they output. You don't need any of this. You can just use a regular voltmeter. You use a piece of crap voltmeter. Just go on Radio Shack and buy one. Now, Radio Shack's not there anymore.
We'll talk about that later.
So you can get it on. You can get a piece of crap voltmeter on Amazon, and it will work the same way. I use this because I process 100 of these a day.
If you're dealing with a lot of solar panel phone chargers, is it good to have a voltmeter around?
Yes, very much so. If you I have parts here to make about 100 of them things.
Okay.
Look here.
Wow. We need the pan, and we just need the panels, right?
Yeah.
Okay.
Well, I also have the panels.
Wow. Okay, cool.
I just figure let's do a small production around here.
Wow. Thank you, Mateo.
Well, in this case, what we're doing is I'm just gonna do the video for one though.
Yeah, of course.
Right. So you set it up here. This is going to be fed a variable voltage from an intentionally crappy power supply.
Okay.
This guy is supposed to be 24 volt, but it goes all over the place.
Oh, because you're testing the regulators?
Exactly.
Oh, okay.
And this is the output. This is 5 volt, 5.20 volts.
An intentionally crappy power supply so that the current being put out is varied.
Yeah.
Okay, just to be clear for everybody. Okay, great.
So this is an analog indicator that I use for other things.
Okay.
This is my digital indicator, and I want slightly above 5 volts. In this case, 5.2. You can change it with the screw here. Again, in this case, I want 5 volts and a bit. So 505 is good. 5.1 is good. Generally speaking, you never want to go below 5. Because otherwise your phone is gonna say, hey, this is not enough voltage, I will refuse a charge. Some phones actually do that.
Okay.
And you want to stay below 5.5 because more than that will just overheat stuff in your phone and not do you any good. Again, this is set to 510, so we're good.
Okay.
Now, if this step is only necessary if you have 5 volt panels. If you have a 12 volt panel, you can skip it. If you have 5 volt panels, you need 2 of the damn things.
Okay.
So the one thing you gotta do is you gotta connect one minus on the panel. So this one here. See the trace called minus. To 1 plus. And what that does for you is that it gives you connection in series. I'm just telling you things.
Is that okay?
Yeah. I'm just telling you things that you can find in a 5th grade science textbook or an intro to electronics, but you should know them.
I don't. I'm just watching.
So
Trying to learn.
What this does for you is that it gives you the same amount of current, but double the amount of voltage. Again, this allows the regulator to bring it down, because this kind of regulate, you can buy regulators that can move voltage up or down. This one can only go down, but that makes it cheaper because it's got a lot less parts. This is like three big parts and two capacitors.
Okay.
All right, so that is this is now our 10-volt panel, which we're gonna use some tape to make it foldable,
Okay.
which is always nice. Again, if you have a 12-volt panel from for like a car use to like trickle charge a car battery, you don't need to do any of this.
And it works, huh, with the same regulator?
Yes, same regulator, just that
Great.
this is an extra step, and I wanted to show you how to do it the hard way.
Yeah.
Okay,
Well,
next.
sometimes it's easier to get the 5-volt panels, or no?
Well, you buy what's cheapest for this
Oh.
kind of thing, really.
Right.
In this case, it so happened that what's cheapest was 5 volts. I got these on Amazon at $4 each, I believe.
Okay.
All right, now we need to actually do the power part. We do the power wiring. Super simple. This is, you know, I'm not telling you anything new here. Generally speaking, you stick with red being plus and black being minus.
Okay. There's 2 wires. Where do those wires go?
Let me show you.
Oh.
So, we connected the plus of one panel to the minus of another panel.
Ah, okay.
If you have a 12-volt battery, 12-volt solar panel, it will probably already have a red and a black wire.
Coming out
And
of
if it doesn't, it will have like a plus or a minus. In this case, we
Okay.
have. So we already used the
them.
the minus here, the minus here to connect these. So we're gonna use the plus.
So to connect the panels, you went minus to minus? Is that
No,
what you did?
you go minus to plus
Minus to plus. Whoa, okay.
on one end. That's what this gray wire is.
Okay,
And on
that's
the
the
other
minus
hand,
to the
we
plus.
go.
Okay.
On the other hand, we have. Let's see, where is it? Here it is.
So how do you know which to which? You just put them side by side and
Yes,
do one
yep.
of the minuses to one of the pluses?
Exactly.
Okay.
The other minus and the other plus go to the actual power wire.
But it doesn't matter which is which?
It does not matter. As long as you're consistent, it does not
Okay.
matter. Generally speaking, in this case, I did it this way because this keeps this wire short, and that will allow me to put some tape here so that I can make them foldable, which is always nice.
Mm-hmm.
Ergonomics is important for this kind of stuff. Now, this wire should be, well, it should be as short as possible, but it should not be too short that it doesn't get in the way. So in this case, for example, we got a bit of extra wire here, and we're gonna actually cut this off because the more wire you have, the more resistance it makes, and the more power you lose. Now, it's not a lot of power loss, however, it is some power loss, so we might as well do this nicely and elegantly. You can use this wire for something else, like making these.
Mm-hmm.
Well, you know, if you want to build these things without wasting stuff, you want to be careful about that. Normally I use my teeth for this, but try not to.
Do not do that. Yeah, not good for your
Yeah.
teeth.
One thing you do not want to be stingy with is solder. You're getting a lot of solder doesn't look very nice, but it gives you a nice, good, solid electrical and mechanical connection. And these things are going to be jostled around a lot, so you're going to need that. Most components these days are surface mount, meaning that there's no longer a hole to where to put the wire. These still do, but it's not the standard anymore. All right, so we got our plus and our minus. What we're gonna do next is we're gonna
You mean that thing when you strip the very top of the
yes,
the
we're gonna
wire?
strip the wires. There is a wire stripping tool for this, but I'm
Mhm.
trying to use as few tools as possible. So, in the tip, this is just again, this is a very simple, very cheap 20-watt soldering iron. Again, you can get these on Amazon. You can get these at Electronics Plus if you're local. Anything you want there, really. Now, these have to actually go in something, so you want them to be nice and neat. There we go. Note that this says in plus and minus, out plus and out minus. Actually, the minus sides of in and out are connected together, so you could, in theory, connect it, you know, with in plus and out minus, and it would work. It's kind of silly to do that, but for some circuits, like my lasers, for example, I do that because it's slightly more convenient.
So what are you doing now? I can't tell with what everything you just said. Is it?
Okay, now what I'm doing is that I've got my
So
plus
you
and
pick
minus
one
from the
end.
panels.
Uh-huh.
It says in plus and minus.
Uh-huh.
So plus is red,
Okay.
minus is black.
Okay.
And all we're gonna do is solder these in.
Plus is red,
The
minus
last
is
thing-
black.
Yeah, it's like on a car, you know, it's like on pretty much anything.
Okay.
Again, don't be stingy with the solder. These things will get banged around. Now here's something interesting, and I'm gonna undo what I just did. Just to show you. This mod, you see these holes here and here?
Uh-huh.
Now normally these are for a screw if you want to build something into a box. However, what we're gonna do now instead is use them for mechanical relief. Let's say that I am yanking these. Eventually, what it will do is that it will break. If you were to take a wire and do a loop around this, on the other hand, the strain would be handled by this little wooden part instead of the part that is also conducting electricity, which is generally healthier. So, let me show you how to do it with a different piece of wire. Again, this is called mechanical relief. It's done normally for industrial electronics. It used to be done in consumer electronics, but we've kind of stopped doing that recently.
So things will break easier?
Yes. Again, you don't. This is not intended. This is intended to be something that you use for an emergency, for example. So you don't particularly care if it looks good. You want it to be strong. So this is what you should do, and then you just pull in the loop. If it doesn't go in easily, you just put a little bit of oil or Vaseline in it.
Now, is there anything extra? I know you were saying, no, wait. Oh, yeah. And this, wait, what plug? Oh, yeah, you're not done yet, huh? Sorry.
Go ahead. What plug we're using? We're going to use a USB plug.
A USB plug? Okay. What I was wondering is because you were saying only in case of emergency, but these people are actually going to be using it on a fairly regular basis.
Yes.
So
And that's an even better reason to make sure that it's robust, isn't it?
that's what I was wondering, if there was anything else we could do to make sure any weak parts are robust and
Well,
that kind of thing that we can tell people.
You can 3D print a box. You can put these in a box. You can 3D print a box. What you can, another thing you can do is you can put some tape on underneath and put in, you know, like an Altoid tin or just pretty much anything.
Where does it go now? I mean, where does that thing go when you?
Well, first off, the first thing we're gonna do is test it.
Okay.
So this guy's got a little light, and this will be your charge. This tells you whether it's getting power or not. In our case, this will be our charging light. Now, the fact that the panels are also running a light means that it's losing a little bit of power. However, that's okay because it's a very small LED and we don't care. We do want to know if it's charging or not.
Okay.
As you can see, it
Ah.
is charging.
Woohoo!
That's important. The next thing we have to do is we have to get a USB cable. We have to get a USB plug in there. Now,
Okay.
there's a bunch of ways to do it. You can, you know, chop one of these things off.
Uh-huh.
You can use a dedicated plug. I don't want to use this because, look at it, it's a big plug.
Mm-hmm.
You connect it like this. This is exactly what exists in your desktop or laptop. But if you do this on this little module, when you unplug stuff,
Yeah.
it will put a lot of strain on it.
Uh-huh.
So we're gonna do instead, we're gonna chop this guy up.
Okay.
In addition, on Amazon, believe it or not, this is cheaper than this.
Okay.
I don't know why, that's just life. So give yourself a bit of, don't cut, you know, stuff super close. Leave yourself a bit of room. Inside the USB plug, you will find 4 or 5 wires. Don't need that anymore. First off, you have to kind of nibble at the outer covering. And inside you're gonna find either 4 or 5 wires. Sometimes you find 4 wires and a metal mesh if the cable that you're chopping up is good. In which case you probably should not have chopped it up, but whatever. This is a cheapy Chinese USB cable, and it does in fact have 4 wires. Now we only care about the red and black. Red is plus, black is minus. These 2 are the data wires. We don't need them. However, what I would like to do is use them for mechanical relief, like we were talking about earlier. This will make the cable stronger. So, in this case, we're gonna pass this through this hole, and we're probably gonna have to force it a bit. Again, because you see the size of these two little power wires. They're very tiny. So you don't want to put any kind of strain on them. You see how it doesn't go in? It just barely doesn't go in because Murphy's Law always hates you. There's two things you can do. You can enlarge this hole. By the way, if your module does not have this hole, I suggest you do something else, like pass it through here. We're gonna use this to kind of make it, give it a little bit of an edge. Now we're nibbling at the plastic cover so that it takes a more conical shape. Which will hopefully make it easier for this thing to come in. Another thing you can do is you can kind of stretch it. Again, this is best done with a pair of pliers, but I want to show you how to do this with one tool.
Mm-hmm.
It doesn't matter which way you send it in or out. It could be up, could be down. Do what you like. The important thing, there we go, it went through. Now, we do something decidedly low tech with it. It's ugly, yes. Will it prevent this thing from breaking? Yes. That's all it has to do. You know, take your time, make a nicer knot if you like. That's entirely up to you. You can do. By the way, this is a little bit of marlin spike. You should definitely also do on this end. I didn't because I didn't want to make the video too long. All right. So we've got these. You ignore these wires. You can cut them if you want. It doesn't matter. Even if they end up touching each other.
I thought you were gonna use them for mechanical relief.
Yeah, I
Oh,
ended
you
up
did
using
that
this
there.
instead.
Oh, it's the same thing. Okay, so now you can cut them. Got it.
Even if they touch each other, you don't really care. The USB protocol knows how to handle with it. Now, some phones, notably the iPhone, will see that they're not actually connected to anything with the data connection and going to slow charge. However, this is a small solar panel, so it would not be able to do more than slow charge anyway.
Okay.
If you are doing this with big panels, then you want to set it up properly. And but that's another kettle of
Favorite
fish.
video. Dun, dun, dun.
So let's again. Don't be stinging your solder. Solder can be expensive, but it is what makes the whole thing work. So again, out plus, out minus.
And all that happens if it doesn't work, if you don't use enough, is you got to use more
Yes.
all over again.
Yep. So again, the point being, try to do it right the first time, and you will not have to do it the second time. Okay. Now all we have to do is move it so that it's a bit nicer on the platform. There we go. And just solder it in. And this is literally all we have to do. See, it was 5 wires. 1, 2, 3, 4, 5. 5 wires, and that gets you a solar panel. If you were using a 12-volt solar panel, you wouldn't even have to do one of them, so that's 4 wires. The point being, you generally want to generate a voltage above what you need, and then you use a voltage regulator that goes down. They're called buck regulators, as opposed to boost regulators. And the reason why I say use them is that they're slightly more efficient and they're usually cheaper.
What do you,
So we're soldering in the USB connector here.
okay.
Make sure that this is flush. And then, again, I suggest you try to make this thing into a little housing.
Yeah, that's what I was going to ask next, actually, about like a housing and how that tape worked.
Okay,
If you're
so
putting it along the part where you...
electrically we're done. This is a
Woohoo!
This is a circuit you can connect. You can connect a phone here. Most importantly, you can connect, you know those batteries that you use to extend phone time?
Uh-huh.
You can connect those and use them as battery banks.
Oh.
So this is basically your full setup. So these things generally contain their own regulator, but some don't. The cheapy ones don't. So we don't want to trust that. We want to have our own regulator. This causes a small loss of efficiency, but gives you a large boost in reliability. So what we got here is that we got this LED, which is not a good source for solar panels, by the way. So if it works like this, it will work pretty much anything else. We have our panels here. We have our... Oops.